Okay, hi, how are we doing? So we're up to Module 13 of Switching, Routing and Wireless Essentials, which is Wireless LAN Configuration. So we're going to look at how to implement a wireless LAN using a wireless router and a wireless LAN controller. So the first section is a remote site using a wireless router. And then most of the rest of it's going to, well, the next two sections are about wireless LAN controllers. And so the first part is basic wireless LAN controllers with pre-shared keys. And the second one is doing WPA2 Enterprise with a wireless LAN controller. So, of course, using authentication. And the last topic is troubleshooting wireless LANs. Okay, so a remote site. So basically, the idea here is that you've got remote workers or small branch offices, and of course, home networks often use a small office home router. These integrated routers typically include a switch for wired client support for internet connection, might be called WAN or internet or something like that, and then wireless components for, of course, antennas for the wireless clients to access it. So these wireless routers typically provide wireless LAN security, DHCP, name address translation, network address translation, sorry, NAT, quality of service, as well as a variety of other features. The feature set will vary based on the router model. Cable or DSL configuration is usually done by the service provider's representative, either on site or remotely before it's delivered. All right, so most wireless routers are pre-configured to be connected to the network and provide services, while the wireless router default IP address, usernames and passwords can easily be found on the internet. Therefore, your first priority should be to change these defaults for security reasons. To gain access to the wireless router's configuration GUI, open a browser and enter the default IP address of your wireless router. The default IP address can be found in the documentation that came with a wireless router, or you can search the internet. The word admin is commonly used as the default username and or password. So basic setup steps are log into the router with a web browser, change your default administrative password. Then of course you'll have to log in again once you've changed it. And then you may need to change the default DHCP server settings. And then, of course, renew your address on the host that you're connecting from, possibly. And then, of course, log in again. And so from there, then you'll actually be able to get into more in-depth settings. So then you can do the wireless setup. And so you can view the wireless defaults, change the network mode, and so identifying which 802.11 standard you're going to use, give it an SSID, configure the channel, ensuring there are no overlapping channels in use. Configure the security mode, so you've got Open WPA, WPA2 or WPA2 Enterprise, and quite possibly some more. WPA3 is at the least close. Configure the passphrase as required for the selected security mode. Okay. Now, configuring a wireless mesh network in a small office or home office, one wireless router may suffice to provide wireless access to all clients. If you want to extend the range beyond the approximately 45 meters indoors and 90 meters outdoors, you can create a wireless mesh. So basically with that, you add access points with the same settings, except using different channels to prevent interference. Extending a wireless LAN in a small office or home has become increasingly easy. Manufacturers have made creating a wireless mesh network simple through using smartphone apps. Okay, so NAT. So, of course, that's network address translation. The wireless router is assigned a publicly routable address by the ISP and uses a private network address for the addressing on the LAN. To allow hosts on the LAN to communicate with the outside world, the router will use a process called NAT, or network address translation. And so, of course, it translates your private local source address to that public global address on the way out, and of course the process is reversed for packets returning. So NAT makes sharing one public IPv4 address possible by tracking the source port numbers for every session and established by a device. If your ISP has IPv6 enabled, you will see unique IPv6 address for each device. Okay, quality of service. Many wireless routers have an option for configuring quality of service. By configuring QoS, you can guarantee that certain traffic types, such as voice and video, are prioritized over other traffic that is not as time sensitive, so email and web browsing being others. On some wireless routers, traffic can also be prioritized on specific ports. So, of course, that does depend on your settings. And so you can actually have a priority list there. So port forwarding. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in or out of a LAN. However, there are situations where specific ports must be open so that certain programs and applications can communicate with devices on different networks. Port forwarding is a rule-based method of directing traffic between devices on separate networks. Port triggering allows the router to temporarily forward data through inbound ports to a specific device. You can use port triggering to forward data to a computer only when a designated port range is used to make an outbound request. Okay, so how do we configure a basic wireless LAN on a wireless LAN controller? So as you can see here, we've got the wireless LAN controller, and then we've got one access point, but typically, of course, going to the trouble of having a wireless LAN controller, you can have more than one access point, but anyway. And so we've got an addressing scheme here as well. So router 1 has got a couple of interfaces, and it's also, of course, there's the switch and the wireless LAN controller, and you've got the access point as well, and you've got the PCs that have got addresses. Okay, so basically the access point is a controller-based access point as opposed to an autonomous one, so it requires no initial configuration, is often called a lightweight access point, or LAP. They use the lightweight access point protocol to communicate with the wireless LAN controller. Controller-based APs are useful in the situations where many APs are required in the network. As more APs are added, each AP is automatically configured and managed by the wireless LAN controller. Okay, so of course you normally configure the wireless LAN controller first. It's not very much different to configuring a wireless router. And so it controls all the access points and provides more services and management capabilities. The user logs into the wireless LAN control using credentials that were configured during the initial setup. And so we've got a network summary page here. And so it's a bit of a dashboard that provides a quick overview of configured wireless networks, associated access points, and active clients. You can see the number of rogue access points and clients as well. Wow. Click access points from the left menu to view an overall picture of the AP's system information and performance. The AP is using the address of such and such. Because CDP is active on this network, the wireless LAN controller knows that the AP is connected to fast Ethernet 01 on the board of the switch. This AP is in the topology is a Cisco AeroNet 1815i, which means you can use the command line and limited set of familiar iOS commands. And so here we're looking at the settings for the AP. Most wireless LAN controllers will come with some basic settings and menus that users can quickly access to implement a variety of common configurations. However, as a network administrator, you will typically access the advanced settings. So for the 3504 wireless controller, you can click Advanced on the upper right-hand corner and access the Advanced Summary page. So from here, you can access all of the features of the wireless LAN controller. Okay, so wireless LAN controllers have two layer 2 switch ports and virtual interfaces that are created in software and are very similar to VLAN interfaces. Each physical port can support many APs and wireless LANs. The ports on the wireless LAN controller are essentially trunk ports that can carry traffic from multiple VLANs to a switch for distribution to multiple APs. Each AP can support multiple wireless LANs as well. So, basically, the basic setup is create the wireless LAN, apply and enable that wireless LAN. Then you then select the interface, and you can then secure the wireless LAN. And so then you can, of course, verify the wireless LAN is operational. You can then monitor it, and then you can view what clients are connecting to it. And so we create the wireless LAN by going in and going new, and away you go. So then enable it by basically ticking the enable box. You can then select the interface, and the interface will carry the wireless LAN traffic. That will carry the wireless LAN traffic must be selected. And so you can then secure the wireless LAN. And so here we're doing a pre-shared key, and that's been typed in there. You can then verify that it's operational. And so here you've got admin status of enabled. And then from there you can monitor it. And so you've got an advanced summary page, and you can confirm that the wireless LAN now has one client using its services. Where do we? Yeah, one client. Okay, and then you can view that client and see what their MAC address is, IP address, and other information. Okay, so now how do we get WPA2 Enterprise running? So PCA, so in the yellow box, is a simple network management protocol and remote authentication dial-in user service server. And so, of course, a radio server. And that's, of course, what we need for the WPA2 Enterprise. The network administrator wants the wireless LAN controller to perform all SNMP logged messages to the SNMP server. He also wants to use a radio server for authentication, authorization, and accounting, or AAA. Users will enter their username and password credentials, which will be verified by the radio server. The radio server is required for wireless LANs that are using WPA2 Enterprise authentication. Now, an SNMP server and radio server configuration is beyond the scope of this module. So to enable those settings on the wireless LAN controller, you click the Management tab to access a variety of management features. And so then from there you can click SNMP to expand the submenus, and then you can click Trap Receivers. You can add a new receiver basically. Then you need to enter the community name, which is sort of like a password, and the IP address, how they will of that server as well. And so the wireless LAN controller will now forward SNMP log messages to that server. All right, how do we get security going? And so, of course, it's under the security tab. And then, of course, you have an option of radius, and then you can configure the authentication, and you can create a new profile, I suppose you could call it. And so from there, you can enter the IP address of the server, a shared secret that's used between the server and the client, and they have to be set on both. And then you click Apply. After clicking Apply, the list of configured radius authentication servers refreshes with a new server listed. Okay. So each wireless LAN configured on the wireless LAN controller needs its own virtual interface. So the wireless LAN controller has 5 physical data ports that can be configured to support multiple wireless LANs and virtual interfaces. The new wireless LAN will use interface VLAN 5, and of course that's its addressing. Therefore, router 1 has been configured for VLAN 5 as shown in the topology, and so here we are there. So we've got a sub interface 1.5, and then that's the router's IP address, and it's all up and happy. So of course that's here. The VLAN interface configuration of wireless LAN control includes the following steps. You create a new interface, configure the VLAN name and ID, configure the port and interface address, configure the DHCP server address, apply and confirm, and then verify that it's all working. So how do we do that? So we create a new interface, and so under the controller, we go to interfaces new, and there we go. We have your settings there, and so you give it a VLAN name, and of course it's VLAN ID, which is 5. You configure the port and interface address. So on there, you can actually, on the interface, you can edit it and then configure the physical port number. And so on this, it will be the G1 interface, the VLAN 5 interface addressing, and the default gateway. Then you can configure the DHCP server address. So the router is also being a DHCP server. And so from there, you can apply and confirm, and away you roll. So you can verify the interfaces by having a look, and you can see that there is VLAN 5 on there as an interface. So, of course, you need to have a DHCP scope. And so, of course, you need to have the scope. You need to name that scope. You have to verify that it's working. And then you configure and enable it. And then you verify. Yeah. So, you can, of course, create a new DHCP scope. Name it. And, of course, they're calling it wireless management. And then in there, you can, of course, select it and then configure the settings. And so you put the addressing in, be that the start and finish addresses. Yes, hello, I'll be out shortly. And, of course, you specify the pool of addresses and the default router address as well. And so then you enable it and apply, and it's all done. You verify the enabled DHCP scope by having a look at it under the internal DHCP, and you can see that it's there, and I'm assuming there would be status enabled. It's off the screen. By default, all newly created wireless LANs on the Wireless LAN Controller use WPA2 with advanced encryption. And so 802.1x is the default key management protocol used to communicate with the radius server. Next, create a new wireless LAN to use interface VLAN 5. And so from there, you configure a new wireless LAN for the Wireless LAN Controller. So again, new wireless LAN, give it a name, an SSID, enable it for VLAN 5, and then you verify you've got AES and 802.1x as the defaults. You configure the security with the radius server, and then make sure it's all working. And so going through the steps, so wireless LANs, create a new one, fill in names and SSIDs, and so then of course you tie it to VLAN 5, and then make sure that AES and 802.1x are the settings. You then need to tell it about the radius server, and then from there it should hopefully be available. Okay, so how do we troubleshoot wireless LANs? So network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. This process is called troubleshooting. Troubleshooting any sort of network problem should follow a systematic approach. A common and efficient troubleshooting methodology is based on the scientific method and can be broken into 6 main steps shown in the table on the next slide. And so basically you identify the problem, and so from that you have users calling in and saying they can't use it or whatever it might be. Someone's got a problem, and then from there you need to establish a theory of probable causes, and of course there could be more than one. And so from there, the most likely cause, you then test your theory. And so basically you go and try and fix that, what you think is the cause, and And then, of course, you make a plan. You then verify that it works. If it doesn't work, that's when you start cycling back to either 1 or 2. What's another possible cause? And so it can be an iterative process where you need to cycle through a few times. You don't always get it first try. And so once you have fixed it, you can then document your findings, actions, and outcomes. So, of course, if you've gone through and made changes that weren't successful, you might want to make sure you put them back to the original settings. But yeah, so it's often an iterative process, as I said. So wireless client is not connecting. If there is no connectivity, check the following. Confirm the network configuration of the PC is using the ipconfig command. Confirm that the device can connect to the wired network. Ping a known IP address. If needed, reload drivers as appropriate for the client or try a different wireless NIC. If the wireless NIC of the client is working, check the security mode and encryption settings. If the PC is operational but the wireless connection is performing poorly, check the following. And so is the PC too far away from the antenna or out of the coverage area? Check the channel settings on the wireless client and check for interference on the 2.4 gigahertz band. It's a common problem. Next, ensure that all the devices are actually in place. Consider a possible physical security issue. Is there power to all devices? Are they all powered on? And then you should inspect the links between the cable devices, looking for bad connectors, damaged or missing cables. The physical plant is in place. Verify the wired LAN by pinging devices, including the access point. If connectivity still fails at this point, perhaps something is wrong with the AP or its configuration. When the user PC is eliminated as the source of the problem and the physical status of devices is confirmed, begin investigating the performance of the access point. And so, of course, check its power status. So to optimize the increased bandwidth of 802.11 dual band routers and access points, you can either upgrade the wireless clients or you can split the traffic. So upgrading the wireless clients is basically have them with a NIC that has is a newer standard and so will perform better. And so, of course, for best performance, all wireless devices should support the same highest acceptable standard. So if you have an old 802.11b connecting into your network, yes, it's compatible, but it can actually slow up everyone. Or you can split the traffic. So the easiest way to improve wireless performance is to split the wireless traffic between 802.11n on the 2.4 and the 5 gigahertz bands. Therefore, 802.n or better can use the two bands as separate wireless networks to help manage the traffic. So there are several reasons for the split traffic approach. The 2.4 band may be suitable for basic internet traffic, but that is not time sensitive. A bandwidth that may still be shared with other nearby wireless LANs. 5 gigahertz is much less crowded than 2.4. So it works better for streaming media. The 5 gigahertz band has more channels, therefore the channel chosen is likely interference-free. All right, by default, dual band routers and access points use the same network name for both 2.4 and 5. It may be useful to segment the traffic. The simplest way to segment traffic is rename one of the wireless networks. To improve the range of a wireless network, ensure the wireless router or access point location is free from obstructions, such as furniture, fixtures, and tall appliances. These block the signal, which shortens the range of the wireless LAN. If this still does not solve the problem, you can get Wi-Fi range extenders, or deploying the power line wireless technology may be used. Most wireless routers and access points offer upgradable firmware that should be periodically verified. On a wireless LAN controller, there will most likely be an ability to upgrade the firmware on all APs that the wireless LAN controller controls. In the figure, the firmware image that will be used to upgrade all the IPs is downloaded. And on the 3504 wireless controller, you can then scroll to the bottom of the page, AP image, and get a pre-downloaded section. Okay, that's it for the chapter. Just a bit of a recap. And so remote workers, small branch offices and home networks often use a wireless router, which typically include a switch for wired clients, a port for an internet connection, sometimes labeled WAN, and the wireless components for wireless client access. Most wireless routers and are pre-configured to be connected to the network and provide services. The wireless router uses DHCP to automatically provide addressing information to connected devices. Your first priority should be to change the username and password of your wireless router. If you want to extend the range beyond 45 meters indoors and 90 meters outdoors, you can add wireless access points. The router will use a process called network address translation to convert private IPv4 addresses to internet routable IPv4 addresses. By configuring QoS, you can guarantee that certain traffic types, such as voice and video, are prioritized over traffic that is not time sensitive, such as email and web browsing. Lightweight access points use lightweight access point protocol to communicate with a wireless LAN controller. Configuring wireless LAN controller is similar to configuring a wireless router, except that the wireless LAN controller controls the APs and provides more services and management capabilities. The interface to view an overall picture of AP's system and information and performance, to access advanced settings, and to configure the wireless LANs. SNMP is used to monitor the network, and the wireless LAN controller is set to forward all SNMP log messages called traps to the SNMP server. For wireless LAN user authentication, a radius server is used for authentication, accounting, and auditing services, and an individual user access can be tracked and audited. You can use WLC interface to configure SNMP and radius server information, WLAN interfaces, DHCP scope, and WPA2 enterprise wireless LANs. There are 6 steps to the troubleshooting process. When troubleshooting a wireless LAN, a process of elimination is recommended. Common problems are no connectivity and poorly performing wireless connection when the PC is operational. To optimize and increase the bandwidth of 802.11, dual band routers and access points, either you can upgrade your wireless clients or split the traffic. Most wireless routers and APs offer upgradable firmware. Firmware releases may contain fixes for common problems reported by customers, as well as security vulnerabilities. You should periodically check the router or access point for updated firmware. Okay, that's it for the chapter. And so, yeah, that's it for wireless as well. I'll see you all later. Have a good one.